Dear learners, welcome back. In this video, we are going to learn about what is seepage pressure, and it is a very important concept. So basically, seepage pressure is the pressure exerted by the water to the soil through which it percolates. So basically, what happens when there is a flowing water in the soil, it exerts a drag force in the soil, and that is known as the seepage pressure. It is this seepage pressure which is responsible for the phenomenon called quicksand condition, and it is of vital importance to the stability analysis of earth structures subjected to seepage. So it is very important concept. Whenever a soil water flows in the soil, it either increases the stability of the soil or it decreases the stability of the soil. So it is very important to understand what is seepage pressure for the stability analysis. Okay, now, if H is the head loss due to the frictional drag of water through the soil mass of thickness Z, then the seepage pressure is given by H into gamma W. As simple as that. Okay. So let's understand what does it mean with the help of a diagram. So here is a soil mass. This brown color is the soil mass, and the thickness of this soil mass is Z. Okay. This entire thickness is Z. Suppose the water is coming in from this direction, this is the inward flow of water, and water is coming out from this direction. Okay, not coming out, uh, it is entering the soil in this direction and coming out from the soil. Okay, suppose the initial head of the water is this much. This is the initial level of water. Okay, now after coming out from the soil, the final level of the water is this much. This is the final level of water. So what happened was the water experienced some head loss, right? The water had experienced some head loss. What is that head loss? Initially this was the head, and finally this is the head of water. So the difference between the initial head and the final head is known as the head loss of water. Okay, as simple as that. The difference between the initial head of water and the final head of water is known as the head loss of water, HL. I'm writing the head loss as HL. Okay, so since the water is in motion, it is flowing, it is dragging the soil mass, and it is getting a head loss. So there will be a seepage pressure experienced by the soil, and that seepage pressure PS is equals to head loss of the soil into gamma W, the total head loss into gamma W. Okay, now can I write this statement PS, that is the head loss, that is the seepage pressure, is equals to head loss by Z. Can I divide it by Z and then multiply it by Z into gamma W? Yes, mathematically it is possible. I can divide it by Z and then multiply it by Z. Why I am doing this? Because this term here is called I. What is I? Pz is equals to Iz gamma W. Now, what is this I? I is known as hydraulic gradient. It is the head loss. Hydraulic gradient means head loss per unit length of the soil, per unit length of the soil. That is hydraulic gradient. What is Z? Z is the height of the soil through which the water is passing, right? And gamma W is the unit weight of water, right? Unit weight of water. So as simple as that, right? So these two equations are equally important. First is seepage pressure is equals to Iz gamma W, or you can learn seepage pressure is equals to head loss into gamma W, so that you can use it while solving the problem as per needed. Okay, now once we have learned about what is seepage pressure, let's learn what is seepage force. So now we have learned seepage pressure is Iz gamma W. Iz gamma W, that means I is the hydraulic gradient, Z is the thickness of the soil, and gamma W is the unit weight of water. Now we know that what is force? Force is pressure into area, right? So suppose the area of this soil mass, the cross sectional of area of this soil mass is A. Okay. So what will be the seepage force then? Seepage force, let's denote it by letter J, is pressure into area. So that it is as simple as that, Iz gamma W into area. Okay. Sometimes in questions or in practicals you might be asked what is the seepage force. If they are asking you about the seepage force, you simply multiply the seepage pressure with area, that is the cross sectional area of the soil. Now sometimes you might be asked about the seepage force per unit volume. Then what will you do? We know that seepage pressure is I Z gamma W, right? Seepage force is pressure into area, that is Iz gamma W into area. This will give you the seepage force. Now we have to find seepage force per unit volume. Okay. So in the same diagram, if A is the cross sectional area and Z is the height, then what will be the volume? So volume of the soil will be how much? A into Z, right? The cross sectional area into Z, height, will give you the volume. So the seepage force per unit volume will be given by uh, it is Iz gamma W into A by Z into A. So this term and this term will get cancelled out, as well as A and A will be get cancelled out. So seepage force per unit volume will be, let me write J by V, that is area by seepage force per unit volume will be I into gamma W. Okay. So we have learned how to calculate the seepage force. Along with that, very simple concepts we have learned about the seepage force per unit volume and what is seepage force. Now, one more important, and that's very important thing to understand. The seepage pressure always acts in the direction of flow. What direction of flow? Direction of flow of water. The vertical effective stress of the soil may be increased or decreased due to the seepage pressure depending on the direction of flow. Okay. So effective stress in the soil is what? We know that the effective stress in the soil is submerged of the soil. This is the gamma submerged of the soil into the height of the soil, right? Now, along with that, if the water is percolating, then the seepage force also applies. So it will be plus minus the seepage stress, and the seepage stress is I Z gamma W. Okay. So why I have written plus and minus? Because let's see in this example. If the water is flowing in this direction, in the downward direction, so it is pushing all the soil particles in the downward direction, and in this case it is increasing the effective stress in the soil. It is increasing the stress in the soil. It is pushing all the soil particles in the downward direction. Okay. But if the water is flowing in the opposite direction, in the upward vertical direction, okay, then what happens? Along with the force of buoyancy which the water applies in the soil, this seepage pressure is trying to make the soil loose. Okay. It is uh, carrying the soil in the upward direction, and the force due to gravity is acting in the downward direction. So what will happen? This force and this force is getting nullified. Okay. So basically the upward force, the upward seepage force is trying to decrease the effective stress in the soil. So that's why plus and minus. So that's what I have written here. If the flows occur in the downward direction, the effective pressure is increased and hence plus sign is used. However, if the flow occurs in the upward direction, the effective pressure in the soil is decreased and hence negative sign is used. Now, that's all for this class. I hope you understood everything very clearly. Bye bye and have a nice day.